Given two strings, the start and the goal string, return true if you can swap any two letters in the start string so that the result is equal to the goal string, and otherwise return false. Hi everyone, we're here today for another Exponent mock interview with Derek. For those of you who aren't already familiar with Exponent, Exponent helps you get your dream tech career with our online courses, expert coaching, peer-to-peer mock interviewing platform, and interview question database. Check it out at tryexponent.com. All right, thanks so much for being here with us today, Derek. Would you quickly introduce yourself for our viewers?
Yeah, absolutely. Hi, my name is Derek. I've been a software engineer for the last 3 years. I'm formerly an engineer at Bank of America, and as most recently, I'm an engineer at Google. And I'm super excited to tackle some coding interview questions today.
Great. Let's get started then. So the question today is, given two strings, the start and the goal string, return true if you can swap any two letters in the start string so that the result is equal to the goal string, and otherwise return false.
Okay, sounds good. Would it be okay if I ask some clarifying questions of
Yes,
this
please go
problem?
ahead.
Yeah. Can we assume that the strings will be non-null or empty or non-empty?
You can get empty strings.
Okay, I can receive that. That's good to know. Thank you. Um, Another question I had would be, can we assume that the strings contain special characters like um, exclamation points or asterisks?
Yes.
Gotcha. Okay, thank you. Um, yeah, that's all the questions I really had about this problem. Um, the first thought that comes to mind about tackling this problem would be what what are we like as far as these two indices, can we assume that I and J are not equal to each other? Like, let's
Yes.
say, like, yeah,
Mhm.
okay. So if that's the case, then we really have to verify that the string is alike in everywhere except two positions at index I and index J. And then everywhere else, it should be the same.
Mhm.
Uh, so as far as way of thinking of a solution to this problem, the first approach, which is a bit of a brute force method, would just be uh, loop through the string, your starting string, and then verify that um well verify that the string is at least length 2, and then compare, and then get to index I and index J, and then replace them, and then keep the rest of the string the same.
Mhm.
So we can do this through like a string builder. So we could create a subset of strings where the first substring would just be from 0 to I. The next string would be a string of length 1, which is just the character at index J.
Yep.
Next substring would just be a substring from I plus 1 to J.
Mhm.
The next substring would be index I, and then the last substring would be everything after J plus 1.
Absolutely.
As a matter of fact, let me see if I could potentially share my screen. So if I were to write a bit of pseudocode for this solution, it would be to through loop through string start, and then in, and then create a replica string. We'll create a string builder that contains the elements of A, but rearranged so that I and J are in two different positions,
Uh-huh.
and then verify that string builder as B is equal to our goal string.
Yes. And just to clarify, so string builder is something specific to Java, right? Why use a string builder instead of a string?
So strings are immutable. So you will be creating an entirely new string that each time you append it to it, as opposed to a string builder that will contain, that will just be one singular object that you can then append it to, similar to an array.
Yeah, okay, that makes sense. Yeah, so then it ends up being a lot more efficient, right?
Right.
Okay, so it looks like in our example, we want to swap the E and the O.
Correct. Yes. So the way I'm thinking about this solution would be to implement a string builder, well, this potential solution, to create string builder as B. And then we would loop through the element of start, where the index is equal to 0. And then J, that's equal to at least I.
Okay, so J always goes from I to the end of the string.
Right.
Mhm.
And then we can compare if, and then we create and then we can append to our string builder in here. And then our fifth solution, I think, would be from, well, the thing about this problem that I'm realizing is this solution has an O of n2 runtime, n to the second, O of a quadratic runtime.
Right.
So it may not be the most efficient solution. So
Because right
I
now
would
we
like
have,
to,
oh,
yeah,
sorry.
I'm so sorry I interrupted you.
Oh, I was just saying, so to recap, because you're trying to generate every possible string where you're swapping two of the characters and just match it against a goal, right?
Yes, exactly.
Yeah.
So if possible, I'd kind of like to scrap this solution
Mhm.
for a potential alternative. I believe that we could actually implement the properties of a set because of its ability of uniqueness. So we can basically split this problem into three potential paths. So path number one, where the lengths of strings start and goal are not equal to each other.
Right, so that's a good edge case to check.
Yeah, I feel like for this solution, the potential edge cases will be if string start is has a length less than 2, in which case we would immediately return,
Mhm.
or if start or string have are not equal to each other, in which case you return also.
Uh-huh.
I believe that the next path we would have to check is if string start and string goal are the same word, in which case we'd have to verify that there's at least 2 letters in that word that are the same, in which case when we switch I and J, the characters will effectively be the same anyway.
So you mean that there should be exactly two characters that differ, right?
Exactly.
Mhm.
And then our third string would be if string start and string goal are the same length but different words. So if start.length is unequal to goal.length, return false here. And if start equals goal, implement a set of characters, and then we could iterate through the character array of our start string
Uh-huh.
and add them to our set. And if the length of the set is less than the length of the string, then we can assume there's at least two characters in that string that are the same value, and we can immediately return true. That makes sense.
So this is just for the start string, right?
Right.
Okay. But we can assume that like whatever string you're given, it might actually have repeating letters. And that should be like okay, right? We don't necessarily return false just because it has repeating letters.
Right. Yeah, we'd only return true if there are repeating letters. Otherwise, we'd go to our third case.
Yeah, do you mind clarifying that case where like we return true if there are repeating letters?
Yes, absolutely. Let me see if I can write this part out. So if we were to, as a matter of fact, I wish I didn't delete that example. In this example, let's assume that both start and our goal are both hello.
Okay.
So if we were to add each character into our start set, we should have a size of 4.
Okay, yes.
Because one of the properties of a set is the uniqueness of their elements. So we can assume that there are since our start set would have a size of, if I can write a comment here, we can assume that the characters in our start lit string have to be, there's at least one of them that are equal to each other, in which case in the characters at indexes 2 and 3 are the same letter, in which case we can swap these two letters to get the same word as our goal string.
Okay.
Hopefully that makes sense. We can try to
So then what are we using the set for afterwards?
The set is only for edge case number 2, where the strings are equal.
Oh, okay. So why use a set instead of just comparing the strings directly?
The problem with comparing the strings directly would be that we'd have to iterate through the string at index I and index j to compare, to see if they're like this, see if they're different values, and to see if that same element is present in another array, in another index. In which case, let's say if we were instead to scrap the set and instead use strings.
What if we just verify first that they are the same length? And if they're different length, we can just return false immediately anyways.
Right.
So if you verify ahead of time that they're the same length, and then you just compare character by character, a linear runtime in order to verify that they're the same string, right?
Correct, yeah. At this case, our runtime would just be O of n.
Yep. Which is the same as adding everything to a set.
Exactly. So our last case would be if string start and string goal have the same length but are different characters. So we can go back to our original example of Holly. In this case, we could instead implement a list of integers that reference the indices of our starting string. And we can attempt to iterate through this list just to check if index at character I in our start string is different than the character at index I in our goal string.
Yeah.
Int I is equal to 0. I is less than start.length I plus plus. Can do is add an if statement to check if start char at I equal to goal char at I. In which case we add to our starting list.
Okay, so in start list, we're just storing the characters that differ, or the indexes of the characters that differ.
Yes, the index of the characters that differ.
Okay.
And we'd only return true if not if one, our starting list has a size of 2, since we need the string should be the same in only 2, except in 2 places.
Yeah, and what is the other condition?
That are at an index I of string A, it's equivalent to the character of our string goal at index J, and then vice versa. So if I were to write this out, it would be if start.char, hopefully that makes sense. I can try to also add this to separate lines. But yeah, so if all 3 of the conditions are met, we return true, but otherwise we return false.
Okay, cool. Yeah, so does it look like your code is mostly finished then?
Yeah, for the most part, this looks like the way I would approach the solution. Yeah, I think that my code is mostly done for this part.
Great. Maybe we could try it out on a couple of test cases.
Awesome, sounds good. So let's see if we can provide our start to be equal to true, and our string goal is equal to false. And then I'll add a second test case for true and root. That way, one of them should exit out immediately, and the other one should fail, because there should be more than one solution. It would take more than one letter to switch to get that target word.
Yeah.
In this one, and then in this third test case, this one should pass. I will try wrapping this in a public static void method. Let's try to run these.
Yeah, and I think this compiler will also require that you wrap all of it in a class called main.
Okay, so at this point, I'd just be adding each test case to our main method. Sorry, I didn't realize it's going to be a little formatting required.
No worries. Yeah, so it looks like close enough is your solution function, right? Which you're then going to call from the main function where you have your test cases.
Mm-hmm. Line 34. Okay. Yeah, it's
So
expecting a compiler error.
Yeah, I think you need to import like array list and things like that.
Ah, gotcha.
I think should it be like public class main?
Oh, thank you.
mhm.
Yeah, and it should be lowercase main because the file is lowercase main.java.
Gotcha. Thank you.
Mhm.
Awesome. Okay.
Great. I think is that what we
Yeah.
expected?
Yes. We passed in test case A1 and A2,
Uh-huh.
where these two should fail because they're not the same length. So they should immediately exit out in our first edge case.
Yes.
In test case B1 and B2, indices 1 and the only indices that are the same are index 2 for character U.
Mhm.
So we'll take more than one character swap to get these work to get to the goal string. So it should also fail.
Uh-huh.
And our third test case, true and true, where indices 2 and 3 got swapped.
Yeah, the
There
E
should
and
only be two characters in our starting list, which should be equal to each other.
Perfect. Yeah. Um, okay. Great. I think this is a great place to wrap up. You did a fantastic job. Thanks for joining us. So I think it's a good time to do a quick debrief. So Derek, what did you think of this interview? What do you think went well, and what do you think you would want to work on more?
Yeah, absolutely. I definitely like to say that uh, I think definitely that I was fumbling on my words a bit near early on in the interview, um, and I definitely think that as far as uh, working through the compiler errors, that I was a bit quiet, talking through the solution. But I think that the problem was pretty good, and that it tested the pros and cons of weighing out the potential paths to this answer, and the pros and cons and the drawbacks to it. So, all in all, I really enjoyed the question. But yeah,
Yeah, I totally agree. So, I really like that when you were initially conceptualizing the problem, you identified some of the invariants of the problem that, in order to get a true, that you needed to have a pair of start and goal strings that differed only by a single pair of characters, and that you exactly swap those characters, right? And I also like that when you started off with the initial original solution of the brute force solution of generating all possible like swaps of characters and matching it, that you very quickly identified that this is a quadratic runtime solution and you were able to pivot to a more efficient solution. Lastly, I also really like that you split your logic into different cases and you also included some good edge cases in there too. So that made it really easy for me as the interviewer to understand what you were trying to accomplish. And then, therefore, if you did make a mistake, I would be able to help you along with that. So as for what I think I would have liked to see more of, so the string comparison part, so I think we ended up covering this, but that it would have been more efficient and resulted in more readable code to just directly compare to strings rather than inserting the characters into sets. And I think I would have liked to see slightly more extensive test coverage, like, for example, covering strings that are different lengths, because I don't think that was, actually, we do have one case of that, actually, but like, for example, like empty strings or characters that are other than alphabetical. Um, yeah, but otherwise, I thought you did a fantastic job. Thank you for joining us today.
thank you so much for having me. I really appreciate it.
Yeah, of course. And for our viewers watching from home, good luck on your upcoming interviews. Bye, everyone.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.